And we're asked to find the expression of the Riemann approximation using n rectangles in sigma form using midpoint approximation. So there's a few pieces of information here. We're given n rectangles, so it's not 3 rectangles or 5 rectangles or 12 rectangles, it's n. And we're given midpoint approximation, and we want it in sigma form. So sigma form means that we're going to get it to be the sum of I equals 1 to n of f of xi times delta xi. And the idea here is we want to replace f xi with what its expression is and replace delta xi with what its expression is, as well as this n up here. But we're not asked to go beyond that. We're not asked to go to closed form yet. We just want to get it in this form. So the first idea is, okay, what is my delta x? Well, my delta x equals 5 minus 3 over little n, because my bounds are from 3, 5. So this is my b value, and this is my a value. So this is going to be 2 over n. Well, this tells us that xi, we need to have our equation. And because we're using a midpoint, xi is going to be a plus I minus 1/2 times delta xn. So xi is going to equal 3 plus I 2 over n minus 1/2 2 over n, which is going to equal 3 plus 2i over n minus 1 over n. So from here, we're going to compute what f of xi is. So what we're going to do is we're going to take this expression here, and we're going to plug it into this equation here. So this is going to equal 3 plus 2i over n minus 1 over n cubed minus 3 times 3 plus 2i over n minus 1 over n squared. So now Rn, because remember, this is what Rn equals. Rn equals the sum of I equals 1 to n of 3 plus 2i over n minus 1 over n all cubed minus 3 plus 2i over n minus 1/2 squared, all times 2 over n. And this is what we're looking for enclosed form. We could expand it, we could not expand it, but this is the end of closed form, or sorry, in sigma form, not closed form, because this is a valid expression within sigma form. Now, if we were to go to closed form, we definitely need to expand before we start solving. But for now, this is what we want for sigma form. Sorry, I just needed to blow my nose there. So now part B, we're using a result from A to find the expression for the Riemann sum approximation using n rectangles and a midpoint approximation in closed form. So now, based on what we've done here, we are basically taking this sum and converting it into closed form. So to do this, what we need to do is we need to expand this expression, expand. And then what we're going to do is we're going to use our summations. So the first thing that we're going to do is we're just going to expand everything. I'm going to do this over to the side. So 3 plus 2i over n minus 1 over n. And because I have it cubed and it squared, I'm just going to solve for it squared first. And then I'm going to take the squared piece and input it here. And then I'm going to once again multiply it by the cubed piece. Okay. And there's going to be an interesting way that we do it just to save us a little bit of time. So we get 3 times 3, which is 9, plus 6i over n minus 3 over n plus 6i over n plus 4i squared over n squared minus 2i over n squared minus 3 over n minus 2i over n squared plus 1 over n squared. And now I'm going to collect like terms. So I just have this single 9. But then I have 6i and 6i to give me 12i over n. And then I have my minus 3n to give minus 6 over n. And then I have my 4i squared, so plus 4i squared over n squared. And then I have this minus 2i over n squared twice to give us minus 4i over n squared. And then I have plus 1 over n squared. So this is my squared terms. And now what I have is I'm going to have 3 plus 2i over n minus 1 over n times this expression, let's call it k, minus 3k. So it's going to be 3k plus 2ik over n minus 1 over nk minus 3k. And we can see why I did this because these are going to cancel. And now what we're going to do is we're going to multiply 2i over n minus 1 over n times this expression here of 9 plus 12i over n minus 6 over n plus 4i squared over n squared minus 4i over n squared plus 1 over n squared.